Okay, we are reviewing for the algebraic manipulation test. It's the very last test that we have that's a normal test. Algebraic manipulation number 5. So I want to go through a few things that you'd have to know. Let's talk about how to change bases, because this one we haven't done in a while. 1/4 to the 2x equals 16 to the 3x. Well, first thought should be, can I rewrite this? And the answer is no. You don't want to do that, because you're going to get really complicated log you'd never be able to solve. So instead, you should try to make those bases the same. 1/4 and 16 can both be turned into a 2. And once you've got the bases the same, it'll be easy from there. Since I'm getting the puzzled look from some of you, I'm going to remind you how this works. So I'm going to rewrite it with a 2x and rewrite it with a 3x. And do you get that I now need to replace the 1/4 with a 2 to the something? 2 to the something. Yes, you can do that. And then you can replace the 16 with a 2 to the something. If you figure out what those question marks are, you'll be pretty much done, because from there it'll be easy. So try some stuff. Okay, well, how about if I make it a 2? Is 2 to the second 1/4? No, 2 to the second is 4. How do I make it 1/4? 2 to the negative 2. Good. There are other ways, yes. There are other ways to do it. I'm doing it with a 2 base. Okay, the 2 over here, 2 to the what is 16? 2 to the 4th is 16. Okay, now that I made those bases the same, they're gone. And that, which is negative 4x, equals that, which is 12x. Now, you got x's on both sides. The proper thing to do is to get the variables all on one side. So which do you get rid of? The 12x or the negative 4x? So you add 4x to both sides. I know this is going to annoy you a little bit, but it equals 0. It's not like you haven't handled things that equal 0. We do that all the time with quadratics. So this is 16x equals 0. What's x have to be? X equals 0. Now let's find out if it actually works, because remember, oftentimes the answers won't really work when you're done. So let's find out if x equals 0 is the answer. I go put a 0 in the original problem. If I put a 0 here, and I put a 0 here, that becomes to the 0, which anything to the 0 power is equal to 1. Anything to the 0 power equals 1. It works. Good. You can know if you're right. Then you take your answer and you plug it back in. It should make it work. Yes, sir. All right. No, because I wanted something that would be 1/4 could turn into. And if I do what you said and take a 2 to the negative 1/2, think about this. I'd be taking the square root of 2 and then flipping it. You were thinking backwards. You wanted me to put it to the negative 1/4 power? Is that what you're asking? Because we have to make this number right here exactly equal to this number. And what a way I did it right now, it was. Because 2 to the second is 4, and then the negative makes it flip, 1/4. Do you have something else you'd rather have me do? I can. There's another way I could do it. I could change it to a 4 to a power. Want me to do it that way, I could. But you just have it backwards in your head, and I'll be glad to explain it more to you if you want. But if you wanted to change these to both have a power of base of 4, that would have been okay. But that's the only other way. All right, and in the end, the answer is just 0. That's the only way it works. All right, that's one kind. Let's look at another kind. Log of 3x plus log of 5 is equal to log base 4 of 4. Solve it. So this falls under the category of condense if you can and simplify when you can. I want to condense that. Log of 3x times 5 equals log base 4 of 4. That's a big hint since those two are the same. What's that equal to then? That's equal to 1. So then log of, I'm going to call it less 15x is equal to 1. And then your go-to strategy, rewrite. Oh, wait, it doesn't have a base. But wait, it really does. 10. Because if it doesn't have a base, we know it's a common log, and that means it's base 10. 10 to the 1 is equal to 15x. That means 10 equals 15x divided by 15, and you got 10/15ths. So x equals 10/15ths. Why would I get it marked wrong, sadly? Didn't reduce. 2/3. All right. Now, if my life depended on it, I'd go back and check. If your grade depended on it, that's up to you. But if it's a test and you haven't got that many problems, it's probably worth checking. So if I actually put a 2/3 in right here, it's supposed to work. What happens when I go 3 times 2/3? Just multiply this. What do you get? 6/3, which would be equal to 2. So this is log base 10 of 2 plus log base 10 of 5 is equal to log base 4 of 4. Okay, well I know that's 1. So then is log base 10 of 2 plus, oh, I can condense those. That's going to be log base 10 of 2 times 5, which is log base 10 of 10. What is log base 10 of 10? It's 1. So 1 equals 1, and yay, it worked. So I know that that answer is good. What if it hadn't worked? What would I have done? Cross it off and call it extraneous. Okay, good. What if you had this? Log of 4x equals log of 17. Can you rewrite that? That's your go-to strategy. No, you can't. So what you going to do? Do we want to get the clump alone? No, that's more like if there was a 3 out here or something, we'd want to get this clump alone. But the clumps are already alone. It's not the get the clump alone deal. So what is it? Because why? These logs are the same base. They can go away. 4x equals 17. So x equals 17/4. And if I really want to prove that, I go back to my original problem. And I know the answer is supposed to be 17/4, right? So let's see if it actually works. I put in a 17/4 here. The 4's cancel. Log base 10 of 17 is log base 10 of 17. It's the exact same thing. Yay. Okay, so I know it worked. So I know that answer was right. All right, let's do a U-Substitution. See if we can handle this one. Actually, they'd probably be more sneaky like this. Let me think. Oh. There we go. Try a U-Substitution to solve that. Anytime you think it's going to be a quadratic, because you have something squared, something that's not squared, it's probably quadratic. Then you do a U-Substitution. Fair warning, phones go away. Nobody's touching them right now, otherwise they'd be taking it, but they're sitting out on your desk, that's not good. Say again? Does it work? I believe this one factors, if you do it right. Can anybody verify that it does factor? Okay, I'm getting a couple people verifying it does factor. All right, here's the trick I think a lot of you aren't noticing. That 3 right there, where can it go? Where should it go? To the front. And now it's not there anymore.
Why can't that 2 on the outside go?
Yeah, because it's outside the parentheses. So then, if you let u equal log x, then you've got a u here and a u here. U squared plus 3u minus 4 equals 0. If you were stuck, take it from there and see if you can handle it. Because it's nowhere near done yet. Question? You mean like this thing I say, let u equal log x? Yes, you need to do that if you want to do a u substitution. Now, if everything was perfect and that wasn't there, I'd have a tough call whether or not I should mark it wrong. But just have it there and we don't have to worry about it. No, it's not always going to be log x. Sometimes we did e to the x is our u substitution. Anything that's complicated and it looks like, boy, this is really complicated and it's got something squared in it, it's probably a u substitution. Okay, so your next step is the factoring it. You should have been able to factor this one without too much trouble. U and u, and then how do I make that -4 factor out? Well, it's got to be a -4, or a 4 and a 1 at least, so I know that. It could have been a 2 and a 2, but a couple of 2's aren't going to make a middle term of a 3 in the middle here. So I knew it had to be a 4 and a 1. And now I want this to be positive and this to be negative. Now I think that's it, so then I check it. There's a lot of checking if you really want your answers to be right. Takes extra time, but u squared, that's good. Outside and inside makes 4u, and a negative u makes positive 3u. And then the last number is -4. Yay, it worked. Final answer. There's two things. U plus 4 equals 0, so u equals -4. And then the other answer I'll do in red here, u minus 1 equals 0, u equals 1. Okay, am I done? No. Because we made this problem easier up here by taking out the log x and putting in a u, we now have to do the reverse and put the log x back in. And then when I rewrite it, there's a little base 10 here, 10 to the -4 equals x. And over here, this is log x equals 1. 10 down there, 10 to the 1 equals x, so x equals 10, or x equals 10 to the -4th. Those are my two answers. If you wanted to, 10 to the 1 is 10, and that's just fine. If you wanted to say that that's 1/10,000th, I'd just be careful that you don't screw it up. Let me think. That's the same as a 1 times 10 to the -4th. That'd be the same as 1, except you take the decimal, move it 4 spots left. 1, 2, 3, 4. 0.0001. Tenths, hundreds, thousandths, 10,000ths. So yeah, you could write it like that, but why not just leave it like that? Totally okay to leave it as, that's what I'm saying, is you could do it that way, but it'd probably be smarter to just leave this alone as 10 to the -4th. That is scientific notation. It's a valid way to leave an answer. Yes? Good question. This is not a negative. I know it seems like it is, but it's just the power's negative. It's just a really small number. Get what I'm saying? This one's not negative either. That's a positive. So neither one of them is likely to screw me up. But if I really want to be sure that both answers work, because we can also make it so that a positive number comes out to an impossible original problem. Because like if I had said log base x minus 4, what if your answer came out to x equals 3? See how as soon as I put in an x equals 3, my base here is not possible? So you can't trust that these are going to work for sure just because they're positive or negative. All right, so then you got to take the answers and stick them back into the original problem and see if they actually work. Why do these work so nicely? Because these are all base 10, see? And if they, one of my answers was 10, you see if I put a 10 here, this whole thing will equal 1. So they'll work out nice. The other one was 10 to the -4th, and then of course that means if this and this are the same, the answer to this whole piece here would be the -4. -4 squared plus 3 times this one ends up being a 10 to the -4th, and this is base 10, so that's also a -4. So anyway, long story short, both of them work. Okay, next, let's talk about let's do a get the clump alone. Solve. Okay, first step is divide by 9. E to the 3x is equal to 18 divided by 9 is 2. And now, whenever you have an x in the exponent, that's what logs were created for. So we need to rewrite. It's your number one strategy. So now I'm rewriting this as log base e. Could I have written ln instead? Of 2 equals 3x. And it's almost alone. I got to just get rid of the 3. Divide by 3, divide by 3. Those cancel. Is x alone now? Yes, so there is your answer. And I know that'll bother some people, but that is an answer that's left in exact form. If you wanted the answer to be like 6.78, you'd be rounding it, because e does not stop. It's not you can't do that. So, final answer, there's no variables in this. You get that there's only numbers in it. E is a number. So that's a good answer. It's done. All right, another version of get the clump alone is this. Try that one. Pausing for a second. Go. All right, so to get the clump alone, first thing we're going to do is add 8 to both sides. And then I get 16 plus 8, which is 24. And then I'm going to divide by 3. And then I get log base x of 5 equals 24 divided by 3 was 8. There we go. I'm stuck. What do I do? Rewrite. X to the 8th equals 5. I just did a that to the that equals that. And then my x isn't quite alone yet, but I'm really close. Put it to the power of what? 1/8. 1/8. And how many of you remembered you just did a positive and negative thing? Ooh, only one per 2 people. All right. Why? Why would I have a plus and minus? You just did an even root to both sides.
But why would that not work in the top?
Okay. You get that square roots of negatives are a problem?
Yes.
Cube roots of negatives are not a problem. The answer to the cube root of -8, for instance, is just -2. It's no big deal. -2 times -2 times -2 makes -8. So it's not like it causes any problem. So the odd roots, you don't have to worry about that. It's the even roots that cause the problem. So watch out anytime it's an even number on the bottom of the little fraction you do, that brings in the plus and minus. So final answer is plus and minus 5 to the 1/8 power. Questions? Oh, good point. I never thought to check it back in the original. Let me look back to the original problem. Can I put in a negative number right there? No, you got me. So this should have been x equals only the positive. And I'm sure many of you thought that through, and that's why you only had 5 to the 1/8. Yeah, sure. Anyway, why didn't the negative work? Because when you plug it back in, it's not allowed there. It's a good question. On the test, if there is extraneous solutions, that you need to identify them. So yeah, if all you would have done on the test was skip this and went right to that, you will not get the credit. You have to notice that, oh, there is a negative answer, and then depending on the problem, that might or might not work. So you would have had to say, oh, there's 2 answers. X equals 5 to the 1/8, and x equals -5 to the 1/8, and that one doesn't work. Like that. Okay, I know that's a lot, but hey, you're in the end of a very challenging math class. Some of you have done very well, but it is a hard class. There's no doubt about it. I mean, just for perspective, when I first started teaching this, a lot of this stuff, as a math teacher, I didn't know. I mean, this is not an easy class. You got a lot of tricky things in here. So, all right, this isn't the hardest test you've ever had. You're going to have, I've already had that one. That was back in trig. The average score still stands at like a C on that test, even with the retakes. All right. And the fun part is you get to have that again on the final. Yay! All right. I think I have covered everything you need to know. So, the rest of the hour is not a screw around time. It's a work time. You've got 2 worksheets I gave you yesterday. I want you to get them all done. I did have a few I told you could skip, of course, but do the ones that I told you to do. Work on them. If you're already done with all of them, have them out on your desk in the done condition. And then if you want to sit there and chat with your friend because you're both totally done, makes sense to me. Okay? And if you want to work on your history or something because it's like really urgent and due to next hour, I'm okay with that. But just have both math assignments done tomorrow. That's all I got for you for today.